Welcome students. I am Kale SL, रयत शिक्षण संस्था RBNB College Rampur. 11 Science Mathematics Part 2 Lecture number 10. Topic number 7 Limits Exercise 7.5. In the previous video lecture we have completed question number 1st of exercise 7.5. And in this lecture we are going to see question number 2nd of exercise 7.5. So let us start. Question number 2nd. Evaluate the following limits. First problem, limit extends to pi by 6 2 times sin x minus 1 upon pi minus 6x. Now all these problems depends upon the substitution method we know. Here in the denominator, if we put x as a pi by 6, here x as pi by 6, 6 get cancelled, so pi minus pi 0, that means denominator 0. So we have to solve this problem by using any method. We cannot put directly x as pi by 6. And here in denominator there is subtraction of this limit extends to pi by 6, this x and pi by 6. There is indirect subtraction, so we have to use here substitution method. So let put here, let pi by 6, this pi by 6 minus x is equal to h. We substitute here this pi by 6 minus x is equal to h, and from this equation we carry this h, we get pi by 6 minus h is equal to x. We get the value of x because we want to put the value of x here. So as x tends to pi by 6, x tends to pi by 6. So if we put here x as pi by 6 and pi by 6 get cancelled. So we get here h as a 0. So we write here h tends to 0. And therefore required limit is equal to limit as, now we change x tends to pi by 6 by h tends to 0. So h tends to 0 to sine of, now we replace x by pi by 6 minus h, pi by 6 minus h, and this minus 1 divided by here pi minus 6x. So we may take here pi minus 6 and x is here pi by 6 minus h, pi by 6 minus h. Okay, so it is equal to limit as h tends to the 0. Now here take 2 common from the numerator. So 2 in the bracket sine of pi by 6 minus h minus, here we divide by 2, so 1 upon 2. When we take 2 common, here 2 is not present, so divide by 2. Again if we multiply by 2, 2 into 1 half, that is 1. And divided by here this pi as it is, minus 6 into pi by 6, 6 get cancelled, that is minus pi. Okay, and minus plus 6 into h, 6h. Now this plus pi and minus pi get cancelled to each other. Now here this is equal to limit as h tends to the 0 to as it is in the bracket sine of pi by 6 minus h minus 1/2 is the value for sine of which angle? That is 30 degree. Sine 30 degree is 1/2. So we write it as sine of 30 degree. So instead of in degree measure we write in radian measure. 30 degree, that is pi by 6. Why we write this sine of pi by 6? Because we use here formula sin c minus sin d. Okay, and in the denominator here this 6h, 2 ones are 2, 2 3s are 6. So it is equal to limit as h tends to the 0. Now use here formula sin c minus sin d. Sin c minus sin d, that is equal to 2 times cos of c plus d. C means this bracket, that is pi by 6 minus h, plus d means this pi by 6, okay, divided by 2, because cos of c plus d divided by 2. and sine of c minus d. So sine of c, see here, this pi by 6 minus h, pi by 6 minus h minus d, d is here pi by 6, so minus pi by 6 and divided by 2. Okay, now in this, here total divided by 3h. Now this plus pi by 6 and minus pi by 6 get cancelled. So it is equal to, here this 2 and 3, these are constant, take outside the limit, so 2 upon 3. Limit as h tends to the 0, cos of, now this pi by 6 and pi by 6 means this 30 degree and 30 degree, that is 60 degree. 60 degree means pi by 3. Okay, this pi by 6 plus pi by 6, here 6 is the denominator, pi plus pi, 2 pi upon 6. So 2 3s are 6, so it is pi by 3. Or we may take here this 30 degree plus 30 degree, 60 degree, and 60 degree is pi by 3. This minus h and divided by 2, divided by this 2 into sine of minus h divided by 2 and divided by here this h, we write here h. Okay, so it is equal to this 2 upon 3 into limit as h tends to the 0, cos of pi by 3 minus h divided by 2 into sine of, here this minus sign take outside the, because we know that sine of minus theta, it is equal to minus sine theta. So we write this sine of minus theta as a minus, here take minus directly. Okay, we take this minus side here. So sine of h by 2 divided by this h. But we know that standard formula is sine theta upon theta, and theta tends to 0, then value is 1. Theta upon theta. So theta is here h by 2. Upon here h by 2, we adjust here 2 and multiply by 2. So 2 into h by 2. Now this 2 take outside the limit. So we get here minus 2 upon 3 into this 2. And now separate limit to this term and this term. So we get here limit as h tends to the 0, cos of pi by 3 minus h divided by 2 into limit as h tends to the 0, sine of h by 2 upon this h by 2. So value of this is 1, because this is standard formula, sine theta upon theta, theta tends to the 0. Here h by 2 upon h by 2 and h tends to the 0. H tends to the 0 implies here h by 2 also tends to the 0. Since here h tends to the 0, h by 2 also tends to the 0, and therefore the value of this is 1. And here directly put h as a 0. This 2 and 2 get cancelled. So we get here it is equal to minus 1 upon 3 into cos of this pi by 3 minus h is 0 upon this 2 into 1. So it is equal to minus 1 upon 3 into cos of pi by 3 minus 0 means pi by 3. Pi by 3 upon 2, that is pi by 6 into 1. Don't write here. So this is equal to minus 1 upon 3 into cos of 30. Cos of 30 is root 3 upon 2. Now root 3 ones are root 3 and root here root 3. Or we may write here 3 as root 3 into root 3. 1 root 3 get cancelled. Okay, like that type. That is here minus 1 upon 3 into cos of pi by 6 is root 3 upon 2. So it is equal to minus 1 upon, we write this 3 as root 3 into root 3 into root 3 upon 2. This root 3 and root 3 get cancelled. So minus 1 upon this 2 into root 3 is the final solution. So now we see here next problem, problem number 2. Limit as x tends to pi by 4. Second problem, limit x tends to pi by 4 in numerator root 2 minus cos x minus sin x and divided by 4x minus pi bracket square. 4x minus pi bracket square. We have given this problem. Now here also in the denominator we have given 4x minus pi bracket square. So if we put here x as pi by 4, 4 get cancelled, so pi minus pi, it is 0. Denominator should become 0. So we cannot put directly x as pi by 4. So we have to solve this by any other method, and here we use substitution method, because here x tends to pi by 4 and there is a indirect subtraction, that is 4x minus pi. So we take here substitution method. Before that we take here in the numerator minus sign common, so it is equal to limit as x tends to pi by 4 root 2, here take minus sign common, in the bracket cos x plus sin x, and divided by this denominator 4x minus pi bracket square. And now we use here substitution method. Put here pi by 4, this pi by 4 minus x, pi by 4 minus x, it is equal to h. So from this we can find the value of x, that is, this implies this pi by 4 minus h is equal to x. We carry this x and h, x to right side, h to left side. And now here as x tends to pi by 4, we have given limit here x tends to pi by 4, x tends to pi by 4. If we put here x as pi by 4, pi by 4, pi by 4 get cancelled, that is h is equal to 0, means h tends to 0. And therefore this limit becomes, this is equal to limit as h tends to the 0, limit as, or we write here, we take here solution of this separately, cos x plus sin x, and then we solve this limit. So take here separate solution of cos x plus sin x. So consider here cos x plus sin x. Cos x plus sin x, it is equal to cos of, in place of x we take here pi by 4 minus x, plus sin of, in place of x we take here pi by 4 minus x. Now both the terms should be same, cos, here cos of pi by 4 minus x, this sin we replace in terms of cos. When we replace sin in terms of cos or cos in terms of sin, we have to use pi by 2 minus this angle. So we want sin, in place of sin cos, this cos of pi by 4 minus x as it is, first term as it is, plus we want this as a cos, so this is cos, but we have to subtract this angle from pi by 2, so pi by 2 and minus this, so minus this means minus pi by 4 and minus plus x. Okay, so it is equal to, therefore we get cos x plus sin x, left side is here cos x plus sin x, it is equal to this cos of pi by 4 minus x as it is, okay, plus here cos of pi by 2 minus pi by 4, pi by 2 means here 90 degree, 90 minus 45, 90 minus 45, it is 45, 45 means pi by 4. So it is cos of pi by 4 and here plus x as it is, plus x as it is. Now we have to use here formula cos c plus cos d. What is the formula for cos c plus cos d? That is equal to 2 times cos c plus cos d. We know the formula of cos c plus cos d, that is equal to 2 times cos of c plus d divided by 2 into cos of c minus d divided by 2. We have seen this formula in the trigonometry chapter in paper first, cos c plus cos d. So it is equal to cos of c here, this pi by 4 minus x, plus d here pi by 4 and plus x, okay, divided by 2, so divided by 2, and here 2 times, so right here 2, so it is equal to 2 times, and this is in round bracket, and cos of c minus d, c here pi by 4 minus x minus d, d here pi by 4 plus x, but with minus sign, here minus, so it is minus pi by 4 and minus x and whole divided by 2. So 2 times cos of C plus D divided by 2 into cos of C minus D divided by 2. And it is equal to, now this minus x and plus x get cancelled. Now this pi by 4 and pi by 4. Pi by 4 means 45. 45 plus 45, that is equal to 90. So 2 times cos of 90 means here pi by 2. 90 pi by 2 and divided by this 2. Into cos of here this plus pi by 4 and minus pi by 4 get cancelled. So here minus x and minus x, minus 2x and divided by here pi by 4 minus h, here instead of x here h, here h, here h, here h, we replace x by pi by 4 minus h. So x by pi by 4 minus h, so instead of x here h, h. So here this minus pi by h and plus pi by h get cancelled. Here pi by 4 minus pi by 4 get cancelled. Minus h and minus h, it is minus 2 times h. Now here this 2 and 2 get cancelled. And we know that cos of minus theta is equal to cos theta. Cos of minus theta is equal to cos theta. So we get 2 times cos of here pi by 2 upon 2, that is pi by 4, into cos of h. Okay, so we get this is equal to this 2 cos of pi by 4, it is 1 upon root 2 into cos of h. This root 2 into 1, that is 2, and 2 write root 2 into root 2 and divided by this root 2 into cos of h. Now this root 2 and root 2 get cancelled, so it is root 2 into cos of h. Okay, so we get the value of cos x plus sin x. We find this cos x plus sin x separately, that is root 2 into cos of h. Now we take this, therefore from 1 required limit is equal to limit as h tends to 0. From equation 1, limit x tends to pi by 4, but we replace x as pi by 4 minus h, and therefore as limit x tends to pi by 4, h tends to the 0. So limit h tends to the 0. In the numerator, root 2 minus cos x plus sin x, and cos x plus sin x is root 2 into cos h. Root 2 into cos h, and divided by 4x minus pi. So 4 and x is here pi by 4 minus h, pi by 4 minus h, and minus pi and whole square, this square. So it is equal to limit as h tends to the 0. Now here take root 2 common, root 2 in the bracket 1 minus cos h, 1 minus cos h, and divided by here the multiply by 4 into pi by 4, that is pi, minus 4 into h, that is 4h, and this minus pi and bracket square. Okay, now this plus pi and minus pi get cancelled to each other. So it is equal to limit as h tends to the 0, this root 2 as it is, 1 minus cos h, we have the formula 1 minus cos of theta. 1 minus cos of theta is 2 times sin square theta by 2. So put the value for formula or value for 1 minus cos h, that is 2 times sin square h by 2. 2 times sin square h by 2 divided by minus 4h and bracket square. So minus 4 square, that is 16, and h square. Okay, so we get here 2 ones are 2, 2 8s are 16. So it is equal to, now take this root 2 outside the limit, this 8 outside the limit, and so we get here limit as h tends to the 0, sine of here h by 2, sine of h by 2, here divided by h and bracket square. This square we write like this. Now angle of sine is h by 2. Angle of sine is here h by 2. Here should be h by 2. So divided by 2 into 2. Okay. So it is equal to this root 2 divided by 8 into this 2 and it's a square. So 1 upon here 4. And limit as h tends to the 0. Limit as h tends to the 0. Sine of h by 2 upon h by 2 bracket square. Now the value of this is 1 because since h tends to the 0, h by 2 tends to the 0, and using the formula sine theta divided by theta as limit theta tends to the 0, that is equal to 1. We know this. And therefore we write this as root 2 into 1, that is root 2 divided by 8 into, we write 4 as 2 into 2. 4 as 2 into 2, and that 2 we write root 2 into root 2. Okay, and this one is 1 square. Now this root 2 and root 2 get cancelled. So it is equal to 1 upon 8 2s are 16 into this root 2. This is the final solution because 1 square is 1. Okay, so last solution is 1 upon 16 into root 2. Now here we see the next third problem, but third is similar to these problems. We see directly fourth problem. Limit x tends to a, limit x tends to a, sine of root x minus sine of root a upon x minus a. Now to solve this problem, here if we put x as 0, x as a minus a 0, denominator becomes 0. Also in the denominator there is subtraction of x and a. So we use here substitution method. But here we use substitution method of twice. We have to use substitution again and again. See how to put here. So we consider this root x. Put here root x as a y. Root x is equal to y. And this root a as b. Root a is equal to b. Now here as x tends to a, and here y is equal to b plus h. Y, this y is equal to b plus h. Now here as x tends to a, as x tends to a, so y tends to, put x as here a, so y tends to root a, y tends to root a, but root a is equal to b, so y tends to b. Okay, and when y tends to b, we put here y as b, b get cancelled, so h tends to 0. So we use this substitution. So this required limit is equal to limit as, firstly we put x tends to a, y tends to b, y tends to b. Okay, because we have to write here root x as a y and root a as a b, so take here limit as y tends to b. So sine of root x as y, sine of y, minus sine of root a as b, and divided by here x as, here if we square this, root x is equal to y, we get x is equal to y square, so y square minus here a, we get a as a b square, squaring this on both sides we get a as b square, in this way. So this is equal to, again see here, limit as when x tends to a, y tends to b, and sine of, in place of root x we write y, minus sine of, in place of root a we put here b, divided by, we want here x, now here root x as y, So square on both sides, we get x as a y square. So x as y square. Here put the value of a. So here root a is equal to b. Square on both sides, we get a is equal to b square. So sin y minus sin b divided by y square minus b square. So here limit as y tends to b, sin of y minus sin of b divided by here y minus b and y plus b. We write the factor using the formula a square minus b square, a minus b and a plus b. So here y square minus b square is y minus b into y plus b. And now here as y tends to b, h tends to the 0. Then we put y as b plus h. Therefore this is equal to limit as h tends to the 0. Sin of, now we put y as b plus h minus sin of b and divided by, here also put y as b plus h, b plus h minus b, here also y as b plus h and plus b. So this is equal to limit as h tends to the 0. Now use the formula sin c minus sin d. We know the formula sin c minus sin d, that is equal to 2 times cos of c plus d divided by 2 into sin of c minus d divided by 2. We have seen these 4 formulas: sin c plus sin d, sin c minus sin d, cos c plus cos d and cos c minus cos d. So here we use sin c minus sin d. That is equal to, in the numerator, 2 times cos of c plus b. See here b plus h plus d here b. So b divided by 2 into sin of c minus d. See here b plus h. So b plus h minus d here b and divided by 2 and whole divided by, here plus b and minus b can cancel. So here h in the bracket, here b plus b twice b. So twice b plus h. So this is equal to limit as h tends to the 0. 2 times cos of, here b plus b, that is twice b plus h divided by 2 into sin of, here b and b get cancelled, h divided by 2 divided by here h into twice b plus h. We write here twice b plus h and write this h below this sign because we use here standard formula. Now here sin of theta here h by 2, here should be h by 2, we adjust here 2, so multiply by 2, okay, and now this 2 and this 2 get cancelled to each other. Now we separate limit to this and this, so we get here limit as h tends to the 0 cos of twice b plus h divided by, here divided by 2, this angle, cos of twice b plus h divided by 2 and divided by this twice b plus h into limit as h tends to the 0 sin of h by 2 divided by this h by 2. Now here since h tends to the 0, h by 2 also tends to the 0, and using the formula limit theta tends to 0 sin theta divided by theta, that is equal to 1. So the value of this is 1 using standard formula. And now here put directly h as 0. So we get here cos of twice b plus h as 0 divided by this 2 and divided by twice b plus h as 0 into 1. And so it is equal to cos of twice b plus 0 means twice b divided by 2. 2 get cancelled, so it is cos of b divided by twice b. But in our main problem we have A, the problem is given in terms of A, so we put the value of B as a root A, B as root A, and so the final solution is cos of B as root A divided by 2 into root A. This is the solution for this problem. Now last fifth problem in this exercise 7.5 and question number 2nd, fifth problem. Limit x tends to pi by 2, limit x tends to pi by 2 cos 3x plus 3 cos x, cos 3x plus 3 cos x divided by twice x minus pi, twice x minus pi to the power 3. In book we have given here power 2, but if we take power 2 we cannot get the answer, so there is printing mistake, so take here power 3. Now here before to solve this problem we write the formula for cos of 3x. We know cos of 3x, cos of 3x is equal to 4 cos cube x minus 3 cos x. So write this formula here. So this is equal to limit as x tends to pi by 2. Okay. Now put the value of cos of 3x as 4 cos cube x minus 3 cos x, and this plus 3 cos x and whole divided by twice x minus pi to the power 3. Now this plus 3 cos x and minus 3 cos x get cancelled to each other. Okay. And now in the denominator there is indirect subtraction of this x tends to pi by 2. We carry here 2, so twice x minus pi. So we use the substitution method. So put here this pi by 2 minus x, put pi by 2 minus x is equal to h, this pi by 2 minus x as h. From this equation find out the value of x, means carry here x to right side, this h to left side, we get pi by 2 minus h, pi by 2 minus h is equal to x. And now as x tends to pi by 2, x tends to this pi by 2, so if we put x as a pi by 2, pi by 2, pi by 2 get cancelled, we get h as 0. H as 0 means right here h tends to 0. Okay, so this step is, this is equal to, or we may write here required limit is limit as h tends to the 0, x tends to pi by 2, h tends to the 0. 4 cos cube, in place of x write here pi by 2 minus h, pi by 2 minus h divided by 2, in place of x write here pi by 2 minus h, that is pi by 2 minus h. Okay, and minus pi and whole cube, so right here square bracket and then cube. So it is equal to limit as h tends to the 0, so it is equal to limit h tends to the 0, this 4 as it is, this 4, now cos of pi by 2 minus h and then cube. Okay, so here it is cos of pi by 2 minus h, pi by 2 minus h, and here it's cube. We write this cos cube like this, cube, and divided by, now multiply by 2 to this bracket, 2 into pi by 2, that is pi, 2 into pi by 2 here pi, minus twice h, minus twice h, 2 into minus h, minus twice h, and this minus pi, and bracket cube. Okay, so it is equal to limit as h tends to the 0, 4 as it is. Now cos of 90 minus theta, here pi by 2 means on the y-axis, then cos change to sine, and in the cos change to sine, also sine of this in the first quadrant is positive, so it is positive. and angle is here h, sine of h to the power 3 divided by this pi and pi get cancelled. Now minus 2 to the power 3, it is minus 8, and h to the power 3. So now this 4 upon minus 8 minus 4 upon 8 into limit as h tends to the 0, this sine h upon h to the power 3. Okay, now these 4 ones are 4, 4 twos are 8, so it is equal to minus 1/2. Now take limit inside the bracket. We write this as limit h tends to the 0 sine h upon h cube. Now the value of this is 1. This is the standard formula. So it is minus 1/2 into 1 cube. Okay, so it is minus 1/2 into 1 cube is 1. So it is equal to minus 1/2. So this is the solution for the fifth problem. In this way we have completed here question number 2 of exercise 7.5, and also exercise 7.5 is completed. In the next video lecture we will see exercise 7.6. Okay, we stop here.